tutorial is the third of a set of tutorials about level 3 probability distributions. So in this tutorial we're going to look at expectation algebra and what happens to the expected values, variances and standard deviations when we multiply the x value by a certain amount or add a value to the x. So we're going to start with all the expected values first. So if our expected value of x is 45 and we multiply every value of x by 3, every single value is increased by a multiplier of 3. So it makes sense, doesn't it, that the expected value of x is multiplied by 3. So it's 3 times the expected value of x. So in this case it's 3 times 45. So we get 135 for our new expected value. Now, what about if we were adding on? So if every value of x had 4 added onto it, every number in our data set was increased by 4, then our mean or our average or our expected value has to also increase by 4. So now we've got our expected value of x and we just add 4 onto it. So our 45 plus our 4, and we're left with 49 for our expected value of x plus 4. Okay, let's combine the two things together. Our expected value of x is 45. Now if we multiply every single value of x by 2, we double it. We double our expected value. So we've got 2 times 45. But then we shuffle every single value in our data set up the number line by 3. So we're adding 3 on. So we end up with 90 plus 3, or expected value to be 93. Okay, so expected values are nice and straightforward. They're changing exactly as our x value is changing. Okay, so standard deviation. We're familiar with standard deviation from level 2 and normal distribution. So if our variance is 9, then for our standard deviation is the square root of 9, which is 3. So let's have a think about what happens when we multiply every single value in our data set by 3. Well, because things are proportionally by 3, if our expected value goes up to 135, and before, with our expected value at 45, and our variance, our standard deviation, at 3, it was down here at 42. Then when we multiplied every single value by 3, our expected value came up to 135. We multiplied this by 3, it came up to 126. So you can see the difference between our standard deviation and our expected value when everything is multiplied by 3. It was a 3 difference. Now look at the difference. We should have a 9 difference in there now. Okay, so our standard deviation is 3 times as big as what our standard deviation was before. All right, now we know that variance is standard deviation squared. So this is going to be 9 squared, 81. But what our formula sheet gives us in our exam, it says that if we have variance of 3x, what happens to our variance is we have this multiplier. We call that, it's just called a, whatever that multiplier happens to be. So it's a squared times the variance of what x was. Okay, so if we look at that, our multiplier is 3, so it's 3 squared is 9. 9 times what our variance was 9. You can see the same result there. Now, it's always better to work with our variance first and then manipulate our variance and then change it to standard deviation. You can see in this example, it doesn't matter which one we work with because the result is the same. But in some further ones that we're going to do, there is a difference. You should work with the variance first. So if we always work with the variance first, we won't have a problem. And we'll look at that in the third example. But if we look at variance and we're adding something or subtracting something to every single value of x, so in this example here, we had our expected value was 45, and if our variance, our standard deviation, was 3, So it deviated 3 that side, and it deviated 3 this side. 3 in between, 3 away from the mean, 3 away from the mean. If we add 4 onto every value, you can see that the spread outness, how much it's spread away from the mean, remains exactly the same. It was a standard deviation of 3, and it is still 3. There is still a deviation of 3 away from the mean. So when we add or subtract a number from the value of x, the spread does not increase. So our spread remains at 3. Our spread here remains at 9. The data does not become more spread out if we add or subtract something to it. So let's have a look at this one here. Remember I said the formula sheet said the multiplier, let me see, let me do that. A multiplier of x, we get the multiplier squared times the expected value, the variance of x. Okay, so our multiplier here is 2. So 2 squared times by our variance, and our variance, remember, was 9. Adding or subtracting does not make the spread any more spread or less spread. It stays the same. So we've got here 4 times 9, 4 times 9, 36. So our variance has increased to 36. Our standard deviation is the square root of variance. Our standard deviation is 6. Okay, so in this example, yes, it is just 2 times the standard deviation. But like I said before, let's always work with the variance, because in the next example, you must work with the variance. Okay, that's the end of this tutorial. If you're working from the ESA learning workbook, your expectation algebra, it's exercise C. So if it's the little booklet you're working from, that starts on page 8.